Good day everybody, I am Keypa Software Architect. I would like to show you in the next 5 minutes Keypa's encryption technology. Everything starts when you first enter your passphrase. Out of this passphrase, Keypa calculates a binary key. And out of this binary key, Keypa extracts a hash. A hash is something like a digital summary. The passphrase is then removed from memory. The passphrase cannot be calculated from the binary key. The binary key itself is kept in memory. The hash is stored in your box. Whenever you enter a passphrase to unlock your box, the same happens as before. Keypa calculates a binary key and then extracts your hash. When it matches, the key is used to decrypt the box. The passphrase is never stored in the box, and it's not held in memory. It can be stored in the master box, and it can be stored on the device. Keypa does not know whether passphrase is correct. Keypa knows whenever a passphrase is wrong. Guessing the passphrase is finite, but it would take ages to do so. Whenever you add something to your data safe, advanced encryption standard algorithm is used to encrypt your data, to finally store it in your box. And that's the point where your binary key comes into the play again. Okay, so far so good. But now let's have a look at what happens when you set up your mailbox. A completely different technology is used. It's called RSA. So Keypa creates a 2048-bit RSA key pair for you. It takes a while. And this key pair contains a private key and a public key. Now the server has to confirm that you really got a unique key. But the server is just interested in your public key, not in your private key. It stays with you. So Keypa encrypts your private key and stores it in a box. The public key is stored as it is. So let's drill down a little bit into RSA encryption. We have our readable data. We have our public key and we encrypt this data with this public key. To get back our readable data, we use our private key. So you can say RSA works somehow like a roundabout. And there is no way to drive against the traffic. The difference is you can switch the directions. You can encrypt your data with your private key. That just means that everybody can read it. But it is sure that you encrypted this data. So let's compare these two directions. When you use your public key to encrypt your data, just you can read it because you need a private key to decrypt the data. That's used, for example, for outgoing mails in your mailbox. Encrypting with your private key means that everybody can read it because just the public key is used to decrypt the data. That's used, for example, for your name and other fields and your image of your mail identity. But RSA can do more for you. That's the roundabout we have seen before. It's time to extend it a bit. Let's assume that's your key. And now let us involve somebody else's key. But it's not our key, so we just have the public key. But that doesn't make any difference in our scenario. We take our data, encrypt it with our private key and also with the other's public key, and we get our encrypted data. So it's time to deliver this data into the other box, and that's the server's job. Okay, well done. And that's the situation we find there. The others pair is complete and our public key is available. Our private key is not needed to make the data readable again. Okay, let us compare the two algorithms we have seen before. The first one is the AES 256. It was established by the US NIST. 256 is the bit length, and that bit length is commonly considered as secure in our days. It is an algorithm that uses the same key for encryption and decryption. That's why it's called a symmetric algorithm, and it's fast. The other one is the RSA 2048, published at the MIT. It uses different keys, why it's called asymmetric. And the problem is, it's slow, about 1,000 times slower than the AES. That runs us in troubles a bit. And that's the way we get around. Here's our readable data. Keypa generates a random binary key. It's then used to encrypt your data with a fast, symmetric algorithm. The key itself is then taken and encrypted with RSA and merged into the result. This technique is also used in TLS and PGP, so whenever you surf a secure internet page, you're using it. Oh gosh, that was complex, and there is even more, but I'm happy that you're still awake. We can be happy that Keypa is doing that for us whenever we are using our box. It also provides a mail certificate, our mail identity, so we can send and receive encrypted mails. It keeps all your data protected, on your devices, in transfer or the internet, on the server. But the most important information that I would like that you take with you is your passphrase is the only way to access your data, and it's not stored anywhere. Thank you very much for listening and have a good day. And always remember, stay encrypted.